Up and running, centering the camera, looks good. Still Friday afternoon, 4:30. Going to make 3 videos. One on simplifying logs. And then that's the one I'm going to do right now, finding some log values. And then we're going to solve some log equations. And then we're going to just do some basic trig on the 30, 60, 90s, and 45s. All right, so this is the 5 problems where we try to find the value of an exponent to convert a base into a quantity that's in the parentheses. All right, so the first one I'm going to do is log base 9 of 3. And we want to know what we have to do to a 9 to turn into a 3. I think we know we got to take a square root. We got to take the square root of 9. And the question is, what's another way of writing the square root of 9? 9 to the 1/2. Okay, so that's from a conceptual standpoint. But how do we take more difficult problems and get that answer of 1/2? Well, we have to write the base, or we have to write the quantity in the base notation. But how are we going to do that, especially when the numbers are smaller? I'm not sure I wanted to say that. Let me cut to the chase and just do the 5 problems. So I'm going to change the number 9 to 3 squared. The word log means I'm trying to find the exponent that produces the quantity in the parentheses, and I don't see an exponent. I have to understand that it's a 1. The rules of exponents come into play. 2x equals 1, and x equals 1/2. And we've been talking in class about that too, meaning perform the operation of rooting, and in this case, it's a 2, so it's a square root. All right, so that's that one. Now we try number 2. Log 49, 1/7. All right, well, what number links these in terms of exponentiating? 7. So 49 is 7 squared. Again, what are we doing? Putting it to an exponent, because that's what we're trying to find, that exponent. That turns this number into that one. All right. 1/7. Well, the activity's in the denominator. 7 to the 1 is in the denominator. So therefore, how do I write it? I can choose to write it as 7 to the -1 because it means the same thing as that. All right. So what's true? 2x has to equal -1, therefore x equals -1/2. That's one more operation. I do know I want to take the square root, right? That 1/2 tells me to take the square root of 49, but I want to put it in the denominator. So we've been talking about what negative signs do. They take numbers and reciprocate them, right? So a negative sign, we'll just call it a flip. All right, so -1/2 was your answer for that problem. Now we're going to do log base 125. I'm finding an exponent. That's what that command means, that I put on top of this. So I'm going to put it right there right now in order to get this. All right, that's what I'm looking for. What do I do to that? But I'll put the x here now, and let's solve that equation. I hope your little brain is saying, oh, this is 120. Looks like I got a flip. I'm anticipating a negative, right? And my little brain is going to try to do it for you right now. So 1/25 and 125 do seem to share a 5 to the x mentality. Yes, it's late on a Friday. This could get very strange. All right, so what's another way of writing 1/25? 5 to the -2. Then that's where I'm trying to exponentiate to get 125. What's 125? 5 to the 3. Hopefully we're familiar with those. Again, rules of exponent, -2x equals 3. So therefore x equals -3/2. I do a lot of squaring here. I hope I change that. Good, I change it up soon. All right, so -3/2. Let's see if we can do the operations. Let's perform the operations, right? All right, so what would I do with that first? I would do that operation. That would change it into this. What would I do next? I would do that operation. That's this. Which is this. Which I hope you can still see. You can. Which is that, and that's what we wanted. So that exponent works. So you would put over here simply the value of that exponent because that's what it's asking you to find. And this is a language. All right, next one, two more. And I upload it and I post it and you practice it, I hope. So here's the next problem. And the reason I picked this is, looks a little different. How's it look different? Yeah, the base isn't written. Well, if you see that word and you don't see the base, it's understood to be base 10 because that's our number system. So it gets a special name. We don't write the 10. But now I think we can say 10 to the what equals 1,000, 3 zeros. We're done. Okay, we wouldn't have to mess with that one too much. All right, last one. And finally got something other than a square and a square root. So I've got log base 8, 1/4. This is called exponential form. Rewriting that, 8 to the x equals 1/4 is exponential form. We change to exponential form and then we work with it. All right, so I'm going to change this to exponential form here so I can line up those equal signs. Gives me a little more organization. I'm going to get the same base. 2 to the 3 is 8. And that's 1/2 to the 2. But what are we going to say? On this right side, we're going to say 2 to the 3x on the left equals 2 to the -2 on the right. So the bases are equal. So 3x equals -2. So -2/3. We'll come over and check these operations that we perform on the number 8. And it's an exponent. So what would I do first? I think I do that one. What is that operation? That means the cube root of 8, which is the number times itself 3 times to get 8. Sure looks like a 2. So I'm going to perform the operation on the 8. That leaves 2 to the -2. I think I can cut to the chase. That's a 4th. And that's your practice on that topic. So I'm just going to push end so I can get out of the classroom. Ta-ta.